Good evening, students. Prishti sir, back with a new question, new example in electrostatics. See the name of the topic, important example in electrostatic field. So as usual, my credentials on the top, and let's proceed. So what I'm going to discuss in this one. First, I'm going to derive the electric field of an arc which is having uniform linear charge density at the center of the arc. Electric field at the center of an arc having a uniform linear charge density lambda. The arc subtends an angle theta naught at the center, as you see here. Okay, this is the radius of the arc is r. So I take this is this dotted line, as you see, is the bisector of theta naught. To the left of that bisector, whatever charge lies, same charge lies on the right side of the bisector. So I take two symmetric small linear charge elements are on both sides of the bisector. So you see, this will produce a field along this line. The element will produce a field in this line. So which will be these two electric fields of same magnitude, but will be symmetrical about the bisector. So their component along the line of symmetry or along the bisector will add up, and the component perpendicular to the bisector will nullify each other. That's the main concept. So see the figure 1, that's what I told you. The arc OAB, this is the AB, subtends an angle theta naught at the center O, theta naught. The vertical dotted line is the bisector of the angle theta naught, as you see here, vertical dotted line. Lambda is the linear charge density on the arc. Take two elemental lengths of rd theta at angle theta at both sides of the bisector. This is theta and this is rd theta length. This small angle is d theta. Similarly, left hand side, this is theta, small angle is d theta, and this length is rd theta. Both the lengths are rd theta and symmetrically situated about the line of symmetry or about the bisector, angle bisector. Then how much charge will be there in this rd theta line? Lambda times rd theta. Here also lambda times r there. This dq. So this dq will produce, this theta tends to 0, so almost a point. So dq produces a field like this. This dq produces a field like this. So both of them will making angle theta. This is theta, opposite angle theta. This is theta, opposite angle theta. So both the DE1 and DE2, they will be making angle theta with the bisector line. But magnitude of DE1 and magnitude of DE2 same. Because why? Because the charge is lambda d theta for both these DQs, lambda d theta, the distance r, this is capital R. So magnitude is same from Coulomb's law. So this magnitude, let's call that magnitude dE. So 1 by 4 pi epsilon 0 lambda into r the numerator is dq by r square, capital R square. That's it. Okay, one r get cancelled. So lambda by 4 pi epsilon 0 r d theta. This is the magnitude of dE. As seen in the figure, which component is getting cancelling out each other? Cos theta is along bisector, this cos theta is along bisector, they will be remaining. But sin theta is perpendicular to bisector to the right for DE1, and sin theta common of DE2 is the perpendicular to the bisector to the left. So they will cancel out each other. So I take the So since these dE1 sin theta, dE2 sin theta cancel out each other, so d cos theta and dE2 cos theta, dE1 cos theta and dE2 cos theta, they add up. Okay. So dE1 cos theta plus dE2 cos theta are the components of the electric field along the bisector. So therefore the electric field will be along the bisector of the angle theta naught, along this dotted line. So the total field along the bisector will be the addition of this dE cos theta, that means integration of dE cos theta. That's it, I wrote here. So E naught magnitude will be, that is direction is along the bisector, the magnitude will be dE cos theta from minus theta naught by 2 to plus theta naught by 2 dE cos theta. So that is lambda by 4 pi epsilon 0 r here into cos theta. I multiply d theta, dE cos theta I am integrating. So this is dE. So multiply cos theta and integrate. Constant term taken out and cos theta d theta integrated from minus theta naught by 2 to theta naught by 2. Because this is from, if this is minus theta naught by 2, then this will be plus theta naught by 2. Or if this is minus theta naught by 2, this will be plus theta naught by 2. Because this is the theta is equal to 0 line, this bisector. Okay, is it clear? Yes. So that's it. So if I integrate, cos theta d theta will be sin theta naught by 2 minus of sin minus theta naught by 2, that is 2 sin theta naught by 2. So lambda by 2 pi epsilon 0 or sin theta naught by 2. Okay, that's very simple. You might be thinking why I'm doing this. This anyway you must have done. Yes, you must have done. I don't have any doubt on this. But what I am going to discuss now is the electric field of a uniformly charged line charge distribution. This is the AB is a line charge distribution. AB is a line having uniform charge density lambda. That is uniform line charge distribution. I want to know the field at a point O. Okay. So this point O subtends this AB line subtend angle theta naught at point O. The AB line subtends an angle theta naught at point O. Okay. H is the perpendicular from O to the line AB, that OE line I am saying. And the bisector of this theta naught is this dotted red color line is the bisector. This is the bisector. Let me write, this is the bisector of theta naught. Okay. This is H is the perpendicular, that is O to E, OE. Here also I should write. Okay. So let us take two elements, two small elements. They are making theta. make angle theta to the right and to the left. The two elements, both of them subtend d theta, and they are situated angle theta from the bisector towards right and towards left. So this element and this element. But see, this length of these two elements will not be same, but the angle they subtend at O are same, d theta, d theta. Okay, so this is the line of bisector line. So about this theta naught by 2 to the right, and about this theta naught by 2 to the left, both are there. So I am taking at angle theta from the bisector d theta element, and d theta element is leading to dx both sides, but the length will be different. What is this dx length? Right hand side dx, this is r d theta. As you can see here, this length is r d theta. This is, let's say, alpha. So then this is also alpha. So this is dx, r d theta, this is dx. So dx sine alpha will be r d theta. So dx will be r d theta sine theta. This is r d theta. This is dx. This is almost 90 degree because this d theta tends to 0. This is an isosceles triangle of r d theta with this. So 90 degrees. So this is dx, and this angle is alpha. So what is the r d theta? Dx sine alpha. So dx how much? R d theta by sine alpha. So dx is r d theta by sine alpha. This is what I got. And at O, the field due to this element and this element, they produce DE1 and DE2 field. That's what you see. This DE2, this DE1. To make cos theta component, because this is theta, this is theta, this is also theta, this is theta. So cos theta component of DE1, DE2, they will be adding up. And their sin theta component will be this, their sin theta component will be, this is DE1 sin theta and DE2 sin theta. Their component will subtract from each other. Okay, I am writing cancel out. Okay, let me remove that cancel out. They say they subtract. If they are equal, DE1 is equal to DE2, then they will cancel out. Okay. So let us see the dq on the dx element, lambda into dx. That's it, lambda r d theta by sine alpha. What is this r? This perpendicular h, this is alpha, then r is h by sine alpha. Yes or no? So r is h by sine alpha. So dq is lambda r d theta by sine alpha. R की जगह I'll write h by sine alpha, lambda h d theta by sine square alpha. So what is DE1 then? If this is dq, then what is the DE1? So apply Coulomb's law, 1 by 4 pi epsilon 0 into 1 by 4 pi epsilon 0 dq by r square. So dq is this, by r square is h square by sine square alpha. So sine square alpha cancel out, 1h cancels out. So DE1 is 1 by 4 pi epsilon 0 lambda into d theta divided by h. So it DE1 surprisingly has not got any terms of r is not there, alpha also not there, only theta. It is DE1 is depends on only d theta. H is a constant, lambda is a constant. Yes or no? So D1 is independent of R. So then what about by proceeding similarly, what will be DE2 also? If I go like this here, that will also be independent of this R, and that will also independent of this alpha 1 or alpha dash, whatever that, because alpha also is not there in the result of DE1. So DE2 will be lambda d theta by 4 pi epsilon 0 h, just like DE1. So they are equal now. So when I told they will subtract d sin theta, d1 sin theta, de2 sin theta, they subtract, but I now have proven that d1 is same as de2, equal in magnitude. So they will simply cancel out. So now we have seen above that d1 sin theta, de2 sin theta cancel each other, and d1 cos theta and de2 cos theta add up. Okay. So they are same magnitude e1 and e2. So their cos theta component add up means I'll simply take d cos theta and sum it up from minus theta naught by 2 to plus theta naught by 2. So what will I get? D cos theta minus theta naught by 2 to plus cos theta plus in up to theta naught by 2, d cos theta. So d is how much? Lambda by 4 pi epsilon h into d theta. So that will be d theta cos theta d theta integration minus theta naught by 2 to theta naught by 2, the remaining constant term writing outside. So that becomes lambda by 4 pi epsilon 0 h 2 sin theta naught by 2. So 2 cancel here. So lambda by 2 pi epsilon 0 h sin theta naught by 2. This is the field, and along which direction? That is along the bisector. So here we have got a very important result, that the field of this uniformly charged linear charge distribution will be at any point will be along the bisector of the angle subtended at that point by the end of the line charge distribution. Yes or no? That's what I say. If this is this angle is sub theta naught, then the electric field by AB length of uniformly charged line charge distribution will be along the bisector of this apex angle theta. That's what here also find. You might be having this in different form, but this is also the form. Here I'm showing it again. So how much that field is? Lambda by 2 pi epsilon 0 h. H is that perpendicular height from O to the line. Lambda by 2 is h sin theta naught by 2. And remember what I got for the arc? Lambda by 2 pi epsilon 0 r sin theta naught by 2. Here the denominator the lambda by 2 pi epsilon 0 r. Here the denominator was lambda by 2 pi epsilon 0 h. सो एच एंड आर को अगर सेम ले लेंगे, कैसे लेंगे? अब ये डायग्राम में आ जाओ. मैंने क्या किया, ये तो लाइन चार्ज है, मैं एक आर्क ड्रॉ किया विथ ओ आर द सेंटर एंड एच एज द रेडियस. ओके, तो एच एज द रेडियस ऐसा के ड्रॉ किया, सेंटर ड्रॉ कंस्ट्रक्ट किया, सो दैट एक आर्क कंस्ट्रक्ट किया. दैट आर्क is getting intercepted by OL line and OB line, this arc. Okay, some name we can give this. Let's say this arc is PQ. So PEQ is the arc, and that also subtending theta naught at O. Yes or no? And this red line is also the bisector of that theta naught for arc also. Okay, and in this case radius of the arc is h. So what will be the electric field due to this arc? Lambda by 2 pi epsilon 0 r की जगह h I can write sin theta naught by 2 along the bisector. And what is the electric field due to AB length of the line charge distribution? This electric field of the arc is same as 2 lambda by 2 pi epsilon 0 h sin theta naught by 2. This is the field due to the line charge distribution. That is also along the bisector only. Yes or no? The resultant field is along bisector and given by this. So I got this for the line charge distribution. And this is for the same. I construct an arc with h as the radius, O as the center, and give on the arc, the red letter, the red color you see, this arc, I give the same line charge density, linear charge density lambda to this also as given to the linear charge distribution, line charge distribution, whatever lambda, same lambda in arc also. Then the field due to arc and field due to line charge distribution will be identical in direction as well as magnitude at O. So electric field is same as the field produced by the uniformly charged straight line AB having linear charge density lambda at point O. That is this arc field and the line linear charge distribution field is same. So this is the very good observation. If a line charge distribution is there, I can replace it by an arc. Or if an arc is there, I can replace it by a line charge distribution. As far as finding the field at a center of the arc is concerned. Am I clear? So the result will be lambda by 4 pi epsilon 0 r. R is the radius of the arc into sine theta naught by 2. That's what lambda by 2 pi epsilon 0 h means r of the arc, radius of the arc, sine theta naught by 2. Here you can see this. Instead of r, I can write h because I have taken radius of the arc as h. So using this result, we can prove that the electric field produced by at the incenter of a uniformly charged sides of a triangle in the next electric field produced at the incenter, we can prove that actually what we can prove here that at the incenter is 0. In next page. Okay, using this we can prove this. Let us see. Let's go to the next page. Did you understand this? This the field produced by this line charge and this arc having the same lambda will be along the same the bisector of the angle and the same magnitude also. The magnitude is lambda by 2 pi epsilon 0 h. H is the perpendicular distance from O to the line, but that is also the radius of the arc constructed here with O at the center. Remember that both the lambdas are same. Okay, let's go to the next page. So next page में चलते हैं भाई. ये देखो येलो आ गया next page. This is a triangle having all three sides having same lambda charge distribution linear charge density, and this is the circle, inside circle touching all the three sides. So O is the incenter, है ना? चलो. So whatever we have discussed in the page 1, I can use that. AB straight line linear charge, what field will it produce at O? That is same as this DE arc. Yes or no? Having same lambda. Okay, this is same lambda. Same lambda. Here lambda, here lambda. This lambda, this lambda. This lambda, this lambda. Same. Similarly, the field due to BC length will be equal to the field produced by this EF arc at center. just as we discussed in page 1. Similarly, field due to AC length will be equal to the field produced by this FD arc at the center. All the fields are vectors. So this is what I did. So resultant electric field at O due to AB, BC and CA will be resultant electric field at this end at O due to DE arc, EF arc and FD arc. Okay, that's what I wrote. The resultant of electric field at O due to O is in center due to AB, BC and CA is equal to resultant of electric field at O due to the arcs DE, EF and FD. But these three arcs make a circle. Circumference of the circle is made by these three arcs. So that means what is the field at the center of a circle having the uniform linear uniform charge distribution? 0. All of you must be knowing. So the resultant of the electric field at O due to arcs DE, EF and FD, that is equal to resultant of the electric field at O due to the uniformly charged circle DEFD circle, and resultant of electric field at center of a circle which is uniformly charged is 0. That means at the incenter, the electric field produced by this ABC three lines of this triangle which are uniformly charged, the field will be 0 at the incenter of the triangle, not centroid or orthocenter or any other that is excenter. Okay, it is only incenter. Okay, so this is extremely important. So this is the proof. So this is thus proved. Okay, I think all of you understood this. This is just application of what I discussed in the page 1. If this is the straight line conductor having uniform linear charge density, then to find the field here, that will be same as if I construct an arc of this radius equal to height, then and is intercepted by OB and OC line, then the field at O will due to the arc and due to the BC will be same along in the direction as well as magnitude. Same argument I can make for AC and AB also. That means due to these three lines, the field produced at center will be equal to the field due to this complete arc, which is a complete circle at the center. That's it. Okay, so we'll go to the page 1 then. So all of you have understood this thing, right? Okay, so I have discussed a very important point for you. This you keep in mind, and it may be asked in examination. You won't face any difficulty henceforth. So all the best for your upcoming examinations, and keep coming to my channel, subscribe it, so that whenever I upload anything new, you will get the notification. So, but if you go through my channel, will definitely your concept will be more clear. That much I can assure you. Thank you all. Meet very soon. I'll meet very soon with a new topic.